Welcome to the On-Premise IT Podcast, the only show that dares to be both on topic or on premise, and sometimes on location or on premises. Each time we meet, we bring together a group of IT experts to discuss a single idea. Today's episode, recorded in concert with Storage Field Day and SNIA's Storage Developer Conference, focuses, yes, on storage. The question is, primary storage, secondary storage, persistent memory, CXL, all this stuff, primary storage really is kind of becoming secondary storage and persistent memory is becoming primary, isn't that right? But before we get into that topic, let's quickly meet who's on the panel today.
Hi, I'm Andy Banta. I am the storage janitor. I have been all over the storage industry, and that's all.
Yeah, and I'm Jim Jones. I'm a senior product infrastructure architect at 1111 Systems.
I'm Vuong Pham. I'm a senior solutions architect. I've been in storage, compute, all those things. So it's all fun.
And I'm Stephen Foskett. I publish this here website and podcast and all that kind of stuff. But I am also a giant storage nerd, and I love Storage Developer Conference because it's one of the only times that you really get to nerd out about storage. Look at the agenda for this week, and it's all about persistent memory and CXL and memory and storage. And, you know, Andy, what's going on in this industry?
There's a lot going on in this industry. It's surprisingly, for having been a storage developer for many, many years, this is my first time attending the Storage Developer Conference. And what kind of surprised me when I looked at the agenda is, hey, we're not talking old school graybeard storage. We are actually talking about memory systems and memory layering and all sorts of various different ways of the ways you can use memory, as Stephen said, through CXL, somewhat through PMEM, and the number of topics that are actually about old school storage are very few. And my take on this is what had been considered primary storage for many, many years is now just it's secondary storage. Primary storage is what's real near the CPU. We need to start applying the same types of things to the primary, to memory that we've been doing to storage for forever. And it's not like we've ever actually solved all the problems with storage tiering. We've just introduced a bunch more problems with memory tiering, and these are all sorts of things that we need to keep doing. You know, we've expanded going from like 5 tiers to 10 tiers, and the problem becomes much, much worse.
Yeah, it seems like it's the constant like drumbeat for data center. It's 20 plus years in this. And I remember back my first job, somebody thought, let's do a RAM drive that had just had a bunch of RAM sitting on a PCI card that you could put a database on, but you better make sure that the system never reboots. Consistently, we've always tried to get the storage as close and as fast to the processor as possible. And this is the next generation, next iteration on it. And it's interesting, but it's always, from my point of view, it's always a consistent question of, okay, so before we had this, and this is what was slowing us down, whether it was a spinning disk and then it became, the SSD or the type of flash. Well, something then is going to slow us down. Where does that, what are we going to use to break up the bottleneck for the next generation or things like that?
I think it's pretty exciting. You're going to have some new paradigms to deal with. You have some new challenges to deal with, new performance to deal with. We talked earlier before we started this podcast, that's like, new bottlenecks. What's going on? New, because it's when I first started this journey of working in IT as a system admin, it's like, wow, bottleneck discovery. That's like the genie, the black magic, because when you talk about any system from my background, it's like understanding biology. It's like, oh, well, you got to know what's this, what talks to what. Now it's at a different level, and we're talking scale beyond that we can think about, and we have to have impact of current operations, future operations, and how things work today and how applications will behave and respond.
Yeah, I think it's important to remember that the whole, von Neumann architecture that we've been dealing with, the whole separation between storage and memory, the only reason we really have that was a technical reason. It was an artifact of the technology involved, and that's why, there has been this historic difference between memory and storage, because memory was physically a different animal. It had to be addressed differently. It was made of different atoms. It was a different thing. Increasingly, memory and storage are colliding. So storage has moved to mostly NVMe over PCI Express. Memory is moving to CXL over PCI Express. Traditionally, there's been sort of bit versus byte versus page versus block, addressing approaches, that sort of thing. A lot of these things are changing, but there is still a difference between persistent and not persistent. There's a difference between RAM and NAND. There's a difference between a lot of these things. But are those differences as significant, and are we really erasing these boundaries?
I think the differences between them are very significant. It's you still actually need to persistently store data. Your bank account can't be something that's in volatile memory. I think that we will always need a way to have completely persistent memory. So I actually addressed this in a blog post several months ago. One of the key things that's happening in the computing industry right now is the idea that the amount of memory tied to a processor is not fixed. That we have gotten to the point where we actually can vary the amount of memory attached to a processor, and we are no longer with this idea that when you buy a server, you end up with this much storage and this much memory. We're now at the concept of you buy a server that has this much CPU, and you can expand the memory as much as you want through CXL, whether it's in the box, whether it's out of the box, doesn't matter. And to answer Stephen's question about persistence, who's to say that we don't actually end up with something like RAID or erasure coding on this memory that is potentially shared between various different systems, and you don't actually need the memory to be entirely persistent as long as it's powered on, and that there's some way that you can actually recover data if some portion of the RAM goes down. I'm not saying this is going to happen, but if we're in this idea that what had been primary storage is now secondary storage, then the new primary storage might end up with various different architectures on it to maintain consistency, to maintain that we actually are storing it. So I think that is one possible approach on doing this. You don't actually need it to be persistent memory as long as there's some way that it's available memory.
Well, that's a key point you're talking there, Andy. One of the first lessons I discovered working in this industry is data integrity. I don't care how fast something is. I don't care how available something is, but even non-available, as long as your data is not compromised in terms of integrity. Jim can speak on that behalf in regards of backup and recovery. That's his expertise, and we can talk about that with architectures of different mediums and different formats and different protocols, like Stephen has addressed. But data integrity still needs to be addressed with that performance add. So.
Yeah, I mean, at the end of the day, really what we're talking about, for years and years and years, is it's all been a very intricate tiering system as far as like data center operating systems and applications use. We have this concept of we have a CPU and we have a cache inside of it, that's where we swap things really quick. And then our next tier down, we would go to memory. And then our next tier, we might, historically, we'd go out to maybe an SSD to load the OS, and then have spinning Rust that we use for the, big bulk storage. Are we inching our way towards a situation where, say, like the 16th generation of Intel CPUs are going to have 2 terabytes of cache on them? Or are we going to re-architect those operating systems or those hypervisors or those whatever to where, okay, it's it's one primary plane, and now that's running at what we used to consider wire speed, and then we have whatever the next level is.
Are you trying to redefine HCI as it is today?
I mean, I think HCI redefines HCI every time we turn around. So,
again, I don't know the exact architectures of all the various different processors that are out there, but I think with the number of cores that they're putting in them, they probably are not expanding the L1 cache a lot. And if they are expanding the L2 cache much at all, you're going to run into consistency issues with the number of cores that are actually accessing the L2 cache. You're going to have you can't expand it so much that you are constantly doing cache thrashing, because different threads want different stuff in the cache.
And again, performance, data integrity in terms of accessing the data from the memory level, and your single thread process could get corrupted. That's something that's it's going to be an inherent challenge, right? So that's a good point, Andy. I haven't thought about how L1 and L2 cache have not incremented as fast as core count. So that's just challenges the architecture of computing.
So one of the things that we uncovered in the Utilizing Tech podcast, which is the sister podcast from Gestalt IT, available, blah, blah, blah. One of the things that we discovered in our season of Utilizing Tech that was a real eye-opener to me, is really relevant to this discussion. CXL as a technology, the core thing that CXL brings to the table is cache coherence. And cache coherence goes directly to what you guys are saying. Essentially, as Andy said, if you've got multiple cores, they all have to decide what is fresh and correct in cache versus what is stale, and then go get the right data when the cache is stale. This is a problem with multi-threaded, with superscalar processors, with certainly multi-core processors, with multi-processor systems, NUMA systems, non-unified memory architecture. All of these systems have to figure out, how do I make sure that any data that I'm getting from cache is the right data? Because there's multiple levels. Most systems today have L1, L2, L3, and maybe more cache. So the chief thing that CXL is bringing, everybody talks about PCI Express and memory expansion and all these kind of things. No, CXL is cache coherence. The protocol brings the ability for a very different kind of tree topology that allows all of these systems to get together. And it was designed in such a way that it looks like NUMA. Essentially, it's a headless NUMA. In other words, you've got a processor that's talking to a device over PCI Express that is memory, and it treats that as if there's another processor there, even though there isn't, because we already solved that problem. And then it allows that to sort of extend and grow and grow and grow. And pretty soon you've got sharing, you've got pooling, you've got memory outside the box. It's crazy talk, but all of these things are cache coherent, and that changes the game.
And CXL, for wanting to do this cache coherency, has actually kicked that can down the road to CXL 3.0. So,
which is a spec. Which is, yes.
There's a spec, and having worked in the storage industry for a long time, when spec actually needs to be turned into code, it becomes very difficult. And the cache coherency is a really hard problem, and contention between multiple sources is a really hard problem, and CXL 3.0 is supposed to magically solve both of these problems. And it's you can spec it any way you want. Actually, generating code that comes up with that that comes up with both the consistency issues between multiple, or the contention issues between multiple processors, and the cache consistency issues is really difficult. So I agree with Stephen that these are topics that CXL is attempting to address. At the same time, it's like where we are with CXL today is not there. At the same time, where we are with CXL today does offer lots of possibilities, even if you're not doing sharing or coherency between these systems.
So yeah, so this is, you actually are hitting the nail on the head for me, Andy, because it feels like it's one of those situations where, so you have the problem of trying to get from theory to implementation. And then I'll challenge that lots of companies have the issue of taking that next step of going from implementation to idiots like me going, well, I bet I can do this thing with that. And it's a use case that's never been intended. And that's going to be, frankly, CXL is one of those magical hand wavy technologies that I'm still trying to truly get my arms around and hug and love. So I'm really looking forward to the conference and being able to attend and really kind of, throw myself into the deep end for it. But I'll be interested to see what happens when, the end user looks at these technologies in implementation and says, oh, okay, so now I can sling things. This will be cool.
So be that as it may, yes, there's always a distance between actually implementing products and merely specifying them. The fact that memory pooling and memory sharing is the marquee product that the CXL consortium is trying to deliver, and that CXL is absolutely embraced by the entire industry. Literally every CPU platform either supports 1.0 or 2.0 now, or is going to in the next version. There's a huge industry momentum behind it. I think what we can say, though, is that the transformational concept behind CXL, which is to say tiered memory, that we can't treat all memory the same, that there's a whole hierarchy there, and that we can run applications and do cool things with memory. Look at what MemVerge is doing with snapshots and cloning and things like that. That whole world is going to transform the stack. To Andy's point at the beginning about, primary storage is not primary storage anymore. Because so far, one thing that's not involved in any of this is SAN and NAS and block and object. None of that. That's the next tier, right?
Makes sense. You want that to happen. You want better processing, more effective processing, closer to ring zero as we can get. And this is one step in that direction, closer. So I've always said, okay, that's nice. You remember when we had the days of hybrid storage? We got SSD with spinners on the back, and the reason was it couldn't keep up. And now it's like the value proposition and economics has gotten rid of that, that spinner layer, and it's better for everybody because now it's less complicated and more consistent. So, now we can address these huge shifts and paradigms of how we compute. And we have smart coders in this industry and demanding people who know what they need and know what they want, and we keep them on track. And I think that's our job as a Sentry to say, hey, don't forget this,
I'll say I'm just going to follow on. You're absolutely right that the distributed storage systems are still going to be extremely relevant. But they're going to be evolving. Like I said, I'm in a situation where spinning disk is still a thing that I have to consider because you have to go to that level of the scale out. And the thing that we're going to have to think about, what is our primary storage today? Absolutely is still going to be very relevant as a primary storage because there's always going to be that use case, whether it be large scale databases, whether it be, file systems or, backup systems where you're always going to get bigger than what you're naturally going to handle with that persistent memory layer. And we're going to have to figure out, and to your point, we've got to get the coding right for how we're going to handle that transition because we're going to stress networks and everything else in between.
I agree with exactly what you're saying. At the same time, what I foresee an awful lot of is there being, well, first off, I want to address something that Stephen said where he mentioned the processor companies were dealing with CXL. Every processor company is dealing with CXL. Add to that every major operating system is also writing software to work with CXL. So VMware is CXL aware at this point, and VMware has some cool features to take advantage of it. And the other major operating system, Linux, actually has all sorts of software that's coming around that deals with CXL as well. So it's not just that the hardware vendors are doing this. The hardware vendors don't do this in a vacuum. The hardware vendors do this because the software vendors drive them to it, and the software vendors are doing this. In fact, I can imagine an awful lot of the CXL expansion, the idea that memory becomes elastic, comes out of the idea that software vendors or software companies want something where it's like, I don't want a fixed amount of memory. I want to be able to decide how much memory there is. Along the software lines, it's when we get into this multi-tiered memory, there's going to have to be lots more software that works with the idea of, hey, I don't just have primary memory. I have all sorts of memory that's out there. And this won't only be like choosing what memory to use. I also fully expect that there are going to be RAID or erasure coding type things that are going to happen with this memory, because if we start dealing with memory this way, we're going to start approaching it differently.
The last thing is everybody pay attention to this space. There's going to be evolutionary and revolutionary approaches to solve this problem. And it's not just VMware. It's not just Linux. It's everyone's going to jump on board and say, oh, yeah, that makes sense. Let's do it. And when we get that momentum, we're going to see some big differences in how people approach their solving their problems, because now they have more tools.
And that's always the fun thing. I think somebody said earlier, I think Jim said earlier, I don't care how it works so much as what I'm going to do with it. And I'm going to come up with an off the wall use case. That's what I always look for at Storage Developer Conference and places like this, because somebody absolutely 100% is going to come up with a wild off the wall use case. And we're going to see some wild new thing like MemVerge or something with persistent memory. We're going to see, or memory. We're going to see some wild new stuff in terms of sharing memory, and some wild new stuff with what used to be primary storage. And on that note, I want to get to another thing that I find really interesting that goes to this conversation. If you go to the companies out there that are making primary storage, the familiar names, NetApp, Pure Storage, ask them what they make. Hey, Dell, what is Dell storage these days? Hey, HPE, what is your storage features? Their marquee features are not your dad's storage features anymore. In fact, a lot of these companies are spending more time talking about ransomware protection. They're talking about things, to me, that rhyme with secondary storage. And that makes me wonder if Andy, I think this whole topic is right on track here, because essentially primary storage is not only being pushed out to secondary storage by memory technologies, but it's being pulled out to secondary storage that's what people want to do with it, and that's what people are buying.
So, right on Stephen's topic, an awful lot of what we consider primary storage companies are seriously working on their multi-cloud presence. The idea that you can have your cloud in your data center, or you can actually transfer it to a cloudy cloud, and that goes exactly along the lines of what secondary storage was 10 years ago. It's like, hey, instead of backing up to a tape drive in your data center, you can back up to the cloud. And all of a sudden we have primary storage companies that again are having secondary storage type features like, hey, we're just part of the cloud. And it's like, cool, you're just part of the cloud because the memory in my box is now my primary storage.
Yeah. And like I said, it's to your point, Stephen, the reality of it is, it seems like everything that's driving like the innovation, and I think it's driving these kind of things as well, is all about the overlay now. We introduced the concept of an overlay, a decade, 15 years ago for the network and other things. Well, now, you've got a security overlay, or everybody wants a security overlay on everything we do. We want to read things in line. And every time you introduce another one of those things that's going to like touch a finger onto the data while it's in flight, now you're increasing the needs for speed for that. So we're just going to keep moving ourselves towards, that storage being faster and faster and closer and closer.
But I want to add one thing to that thought. When you look at storage and its role in data processing, because the speed hasn't been as fast as RAM, it's always been somewhere to park your data long term. So I don't think it has more relevance today other than a data archive, other than protection from ransomware, but still accessible quickly for backup and recovery. So your point, Andy, secondary primary storage paradigm is challenged. It's there. The gauntlet's been thrown, and we have to rethink our paradigms and how we do things and how we accept what's been given to us by the manufacturers, because artificial limitations, Stephen, you brought up about RAM, it doesn't need to be there today. There are means that we can go around that and break boundaries and challenge how we solve problems.
Yeah, I can't agree more. So, the ransomware discussion itself, the reality of it is, we're looking at mean times in minutes, not days at this point, when we go from attack begin to there being an expectation of us being able to identify it. And so there's a lot more pressure. We're going to have to be more intelligent with it, and then what we want to do. I can't agree with you more.
Yeah. And it's just reinforcing this entire idea. It's like for many years, the NetApps and the EMCs and the Dell storage, or Dell storage, whatever you want to call them, kind of viewed the secondary storage vendors as their competition, like the Cohesities and the Rubrics and whoever, and went after their business. And they've basically taken over the function that the secondary storage vendors had, and at the same time didn't pay attention to what was beating at their front door, which is the new primary storage.
Yeah. I mean, Andy, I'm just waiting for the CXL implementation that lets me write directly down to tape, and then we can call it feature complete.
I want to see the CXL operation that lets us go to DNA, and then goes down to decompressed RNA. So then we have transcription, and hopefully less transcription errors there, because that's what's going to happen. Remember, we're dealing with binary zeros and ones. DNA is base 4, and then you decompress that to base 2. It's just amazing. So
I believe somebody's actually working on a fiber channel over token ring interface to do the memory to tape interface.
Yes, fiber channel over token ring to DNA. We're gonna plug it right into our arms. So I think this is amazing.
I am my own
honestly.
backup.
It's like Johnny Mnemonic. 50 gigabytes in a brain, amazing. Or even was it megabytes? I don't know. So, but let's kind of get around this. I think this whole discussion has been incredible, because it's so true that memory technology and advances in memory technology are kind of muscling storage out of the picture a bit. Storage technology is kind of muscling, primary storage is muscling secondary storage out a bit. Secondary storage is kind of muscling, the old archives and everything like that. Everybody's kind of fighting for a place. I want to quickly go around the table and wrap this up on the premise. Is memory edging out primary storage and making it secondary storage? Let's start with Vuong.
Absolutely. There's no reason why it can't. There's more reasons why it should, and there's advantage. So as we evolve and force ourselves to change how we do business and change how we solve problems, I think it opens a world of opportunities, and it's going to accelerate our discovery of new solutions and faster compute times.
Yeah, I agree as well. It absolutely is. I mean, the requirements that are there. We need to be able to do more things with our data and do it faster. And the only way you can really do that is to make the technology where you read from faster. And so we're going to see more and more of this, and it's going to be exciting to see what comes next.
And I'll throw in the contrarian aspect of what's happening right now isn't really new. It's just doing the exact same things of storage tiering that we did previously on memory tiering. And if we actually try to draw these lines between what the distinction is, we're missing the point of what's going on. There's a zillion different software engineers out there that are going to treat tiers of memory just like they treated tiers of storage and make it do magic.
And as for me, absolutely, I think that I completely agree with this premise, and I can't wait to see what happens. That's the cool thing. I love to see the crazy innovation that we're going to see around memory, around storage, the new primary, the new secondary, the new whatever. And I can't wait to sometime in the future when I can fit an astonishing, I looked it up, 80 gigabytes of memory in my brain. That would be unbelievable. So before we go, where can we continue this conversation and remember this podcast? Let's go in the reverse order of how we started. So Vuong, Jim, and Andy.
I think we should be, definitely pin Storage Field Day, pin Tech Field Day. You're going to be some fantastic conversations, and we want to hear questions from people who are listening to this podcast. We want to make sure that we're there to advocate your concerns and questions, and we're always available. Stephen has great great avenues for connecting with everybody.
We always hope for great revenue. But yeah, I mean, I think a good place to continue this conversation might be, I don't know, a developers conference where we talk about storage. Looking forward to that. So we'll leave it at that.
And it's absolutely Storage Developer Conference and Tech Field Day or Storage Field Day 26 are going to be awesome events. You can catch up with me at Andy Banta on Twitter and andybanta.substack.com. And oh, by the way, I am talking about memory tiering Thursday morning at 10 a.m. at the Storage Developer Conference. So I have no idea where this topic came from, but I will be talking about memory tiering and how to manage it on Thursday morning. So why don't you join me?
Yeah, and if you need to reach out and have a question that you want to talk about DNA plugin to Token Ring, just reach out to me on Twitter at digital_kung fu or on LinkedIn under my name, Vuong Pham. It's all good. I'd love to have a conversation.
Yeah, you can find me at Kool-Aid.info for my personal ramblings, and then Kool-Aid IT pretty much everywhere that involves the word social media.
And as for me, you'll find me at Foskett on most of the socials, including, the X Twitter, though I'm not as active there anymore, and Mastodon, LinkedIn. That's where seems to be a lot of this stuff happening. And of course, as mentioned, check out the videos for Storage Field Day. Watch it live tomorrow, the 20th and 21st of September 2023, but also watch it on Memorex, all 80 gigs of it in my brain on YouTube, anytime you want at YouTube/TechFieldDay. If you enjoyed this discussion, please give us a rating. Please give us a subscription. You'll find us in every podcast platform out there. We'd love to hear from you. Give us some feedback. This podcast is brought to you by GestaltIT.com, your home for IT coverage from across the enterprise. For show notes and more episodes, go to GestaltIT.com/podcast. Thanks for listening, and we will see you next week.